Our last unit for Geometry A was Unit 3. This one should be fresh in your head because we just took like 2 tests on it, so this should be easy. The length of a rectangle is 20 and the width is 15, so we're talking about 20 to 15. Find the ratio of the width to the length. The width is, wait a second, the width is 15, the length is 20, so flip that, and then we're going to reduce it, 3 to 4. Ratios don't have units, so you don't need to worry about the meters. As long as they're both the same, you can cancel them out. So the ratio would be 3 to 4. This guy, CD, that's this over DB, so that's what I'm looking for, I have a feeling. X over 5 equals CE, that's this guy, 10 over EA, 4. Cross multiply, 50 equals 4 times X, that means X is going to be about, give or take 0, because it's exact, 12.5. What do we got? Solve the right triangle. Ooh, trigonometry. Nice. This is, let's see, let's call this guy x. So I would do x squared plus 10 squared equals 15 squared. X squared plus 100 equals 225. X squared equals 125. Square root both sides. That's going to be about 11.18. So this side I don't really need trig because it's Pythagorean theorem. Now I need to find, let's call this angle B, let's call him y. Let's see, I want to use 10 and 15, so that's the opposite side, and that's the hypotenuse. Opposite hypotenuse. So, sine of y is opposite over hypotenuse. Wait a second, I don't know why. So I better use inverse sine of 10 over 15. That'll give me my y. Once I do that, the inverse sine of 10 over 15 is going to be about 41.81 degrees. 41.81. Now you could subtract, but since I like doing trig so much, I'm going to do trig again. I'm going to find angle A. Let's call this guy Z. I'm going to find Z by saying adjacent over hypotenuse. So that would be cosine. Cosine of Z is adjacent over 15, 10 over 15, adjacent over hypotenuse. But I got to use the inverse cosine. The inverse cosine at 10 over 15 will give me my Z, which Z is going to be about 48.19. And the cool thing about doing it this way is when I add them together, 41.81, 48.19, they get 90 degrees, so I know I did it right. That's awesome. It says nearest 10th, so I should probably do that. 41.8, 48.2. I don't want to mess that up because it does say round. All right, what else we got? Ratios and areas. Okay, let's see. What do they want? Find the unknown area. So I'm going to find this area. I'll call that my x. I remember that if I do side over side, if I call this figure A and this figure B, the side of A and the side of B, the ratio of the sides and the ratio of the areas, area over A, area over B. Let's see. Sides and areas, those don't have the same ratios. Oh yeah, you have to square this guy. You have to square the ratio of the sides or perimeters, since sides and perimeters are the same. Square this guy, and that'll give you the ratio of the areas. So side of this figure, that's 7 over this guy's 9. If I square that, I'm going to get the area of A, that's what I want, over the area of B, 210. Best way to do this is probably to just simplify that fraction. 7 squared over 9 squared is 49 over 81, because now it's really easy to cross multiply and divide, and you get x is 127.04, and these are inches squared, and that's it. We're ready for the final. Woo! Let's do it!